Hello, hello, hello. Welcome to Twitch Thursdays, and I'm Mofi, and I'm back.
Finally.
I've been out
You've
for
been
about.
missed?
I saw the beginning of the Twitch stream before. You guys were extremely happy that I was not here.
Yeah.
No, you were. But like, it's good to be back, and let's get started, right? Without further ado. So today we are gonna talk a little bit about Openshift. Are you familiar with Openshift, Nick?
Yeah, you talked a little bit about it before. I heard it's kind of like Kubernetes-ish. Not really, but something that you'd know that I don't.
Okay, well, that's why we're here. We're going to talk a little bit more about what Openshift is and how this whole thing came about, and we're going to learn what people need to know about Openshift. So let's jump to my sweet little presentation that I have set up here. So the title of the talk, actually I'm giving this talk in a meetup later today anyway, so it's a good practice here as well. So first things first, app idea to Openshift. So the main goal of Openshift is to make it more suitable for building apps instead of just, Kubernetes is very infrastructure heavy. It's a lot more thinking about giving you kind of infrastructure there, and you as a user decide what to do with it. Openshift, main goal of Openshift is to be an application platform. So if you think of Kubernetes as IaaS, it's not necessarily IaaS. It's not necessarily giving you bare metals and VMs. It's a little bit more than that.
What is IaaS?
Infrastructure as a service.
Okay.
Where have you been living, Nick? Anyway, so Kubernetes is not necessarily just infrastructure. It gives you some application capabilities, but it's not a complete PAAS either, right? You as a user has to touch a lot of knobs, do a lot of work, and we're gonna see a little bit later. But a lot of the work in Kubernetes, in terms of CI/CD workflows, actually revolve around external things, like your Travis. Travis is external. You push your code to Git, that goes to Travis. Travis does some change, push to Git again, that goes to Travis again, comes back as a YAML change into your cluster. So it's going in and out of the cluster a lot of the times.
Okay.
So OpenShift kind of changes that a little bit. We're gonna see how in a second. So OpenShift and Kubernetes, I think the relationship is OpenShift is greater than and equal to Kubernetes. It has everything Kubernetes has, and then some more things on top. So any OpenShift cluster you have, you can actually use that exactly as you would use your Kubernetes cluster. And it would just work, because most of the things, every single API resource that are available in Kubernetes are also available in OpenShift. So that's number one thing you have to understand. So it is Kubernetes at the very core of it. So again, I'm pretty sure our viewers already know everything about Kubernetes, but let's just give a quick refresher what Kubernetes is, right? So Kubernetes is a container orchestration platform. And it just basically take your containers, run it up, spin it up as many copies as you need, and set up deployments, set up services so that people can access from outside. So Kubernetes, basically what it gives you is compute resources, and as a user you get an API. You have the kubectl that you can use to access those compute resources. And finally, it's at the very bottom of it is the overgrown scheduler. Kubernetes has a scheduler that knows how much resource it has available and where it can fit new things as it comes. And Kubernetes will, as you put new things onto it, Kubernetes will keep finding space if it can to schedule those. So it's just like a big scheduler. So why would you use Kubernetes, right? We talked about this many times, but Kubernetes, the basic reason most people would use Kubernetes is the features Kubernetes brings you. All these things in the list, if you read down, many of those things are available in other platforms as well. People have been implementing these things in VMs as well, but the problem is those are mostly roll your own solutions. Whereas Kubernetes comes built in with all these things. That means, first of all, you don't have to spend engineering hours building these things. Number two, these things will get updated and managed by an open source community rather than your team as things change and you have to security updates and other things. So Kubernetes kind of brings all these things pre-baked so that you don't have to think about it. So best-in-class solutions, you just get it for free. So in a Kubernetes workflow, right, this is kind of how you do things. Right? You write your code, you write some Docker file, so you build your code if you it's a compiled language. You containerize if you need to, and in Kubernetes you almost always need to containerize. It could be a Docker container or CRI-O or Podman, any kind of container system you're using. And finally you write some YAML files and apply those configs to your cluster. And then you set up some ingress rule using either load balancer, node port, or ingress so that people can access your code from outside. That's kind of like the basic flow. Right. And I'm pretty sure your code, kind of like the application you're deploying on Kubernetes, uses the similar idea.
Yep, I think I do everything you said there.
Yeah, but like I think you took it to the next step now. There's a CICD context, right? So if you want to do actual CICD, next step is you push your code to some version control system, in example Git, and that will kick off a job in some sort of like CI/CD platform.
Yep.
And Jenkins circle CI go cd Travis. I spelled Travis wrong, so don't kill me. So it starts a build of some sort, and it will build the image and push to some registry. It could be a private registry or public registry, and finally that would change some YAML versions, and that will get again pushed back to your Git.
Right.
And that will start another job. And that job, again, you see like you're going in and out of your cluster. You're in a cluster, go to Git, and then starts Travis. Travis comes back to Git. That goes to, also Travis sends it to image registry, goes back to Git, and starts another job. And
actually, I think the one thing I don't push the YAML changes to.
Okay.
I just have like a YAML template.
Okay, that's fair. But like the idea, some people would want to then have the YAML changes also kick off the job, but like you could do that either way. And then finally that goes back to the cluster and comes back as a change on your cluster. This is not necessarily wrong, but also it is, a lot of the things has to be touched for things to work out. So before we talk about how OpenShift does it, let's talk a little bit about what is OpenShift first, right? And in the OpenShift website, they would claim to be Enterprise Cloud Development PAAS, Platform as a Service. So they are adding things on top of Kubernetes to convert Kubernetes into a platform, rather than just being this thing where you could do the X, Y, and Z. OpenShift is a lot more opinionated, right? It has a lot more opinions about how you should build your code, write your code, or build your languages, things like that. So if your workflow kind of matches the way OpenShift does things, OpenShift is the best solution you can think of for that matter, right? Because your workflow just matches one-to-one. If you do things completely differently than OpenShift, OpenShift takes pretty much almost always the best-in-class path through these things. So if you're doing things completely differently, you should probably rethink if doing things differently does actually make sense for your workload, right? So OpenShift is application first. Kubernetes is great, it's fun to learn, and I have a lot of fun learning Kubernetes and playing with Kubernetes, but as a main value of your code only comes when it's deployed as an application to the cloud. And OpenShift, we're going to see the examples what I mean by that, but OpenShift is meant to be application first. It has a lot of automated workflow just pre-baked into OpenShift, like some bunch of language choices. For example, your application is written in Node. OpenShift already has an image builder for Node built into OpenShift. So you can just push your code on your Git without even writing a Docker file. OpenShift will look at your code and understand how to build that image for you. And finally, OpenShift basically runs the same literally in every single cloud. So even with Kubernetes, each cloud has a little bit of a flavor of Kubernetes that is changed, right? EKS in Amazon is a little bit different than GKE, it's a little bit different than IKS, it's a little bit different than AKS in Azure. For the most people, those differences probably doesn't really make much difference if you're just on the same cloud. But if you want to move into this multi-cloud world where your workload is distributed among multiple clouds, having a software that is uniform across cloud is probably pretty great. So OpenShift kind of gives you that because it's running on top of other clouds, but the software itself, the core of it is still the same. So your workload can literally be shifted or even routed from the same master to multiple clouds.
Gotcha.
So that was all the slides I wanted to show. So I'm going to quickly go over the OpenShift console and all the things OpenShift has. So for today, I have OpenShift running on IBM Cloud. But as I mentioned before, OpenShift, if I had it running on Google or Amazon or Azure, it wouldn't be any different. Ooh, 0 resources found. That's bad. Okay, no, it's back. Okay, where's my terminal though? So basically, if you just click on OpenShift Web Console, this is one of the things in Kubernetes people kind of don't really have too good of, is the console, web consoles. Kubernetes does have a dashboard that you can access, but it's not necessarily much. It's more like to see rather than to control Kubernetes properly with. So dashboard is kind of like one of the weak points of Kubernetes, in my opinion, and that's where OpenShift Web Console actually really shines. As a user, you could do everything on the terminal, but you can do exactly one-to-one everything on the web console as well. So this is something OpenShift did really well, and it's very useful for a user. And it doesn't matter if you're a power user in the terminal or you are an operator that don't really want to touch terminal that often, you can get the same amount of work done based on what your preference is.
Cool.
So that's like the base thing. On the right side, you have some projects that you have running on your cluster. So right now I have like the default project. And Kubernetes also, in Kubernetes, you're familiar with the term namespace?
Yeah.
Okay.
A little bit.
A little bit. So namespace is basically you just create a namespace, you put application in that namespace. OpenShift has the same idea of a namespace, but they call namespaces projects. So the idea in OpenShift is on the same cluster, you will isolate your like workload by project, by namespaces. So each project will be separate, completely separate project, and you will have different things in that, different resources there, and different users even. So like in the same cluster, you and I can work without interfering with each other's projects.
Gotcha.
So that's kind of the basic structure.
So you have about 16 projects going on here?
So not all of them are created by me. So there are a bunch of projects. So namespaces, as I said, are a bunch of like default namespaces. And we can actually take a look at that from the terminal real quick.
So whenever you started this OpenShift thing, did it come with like these 16 projects
It
like
didn't,
already good to go?
It didn't come with, except for example health, it actually came with everything else.
Gotcha.
Oh, well, sorry. I think this one was created.
Oh, yeah, I think it said like scroll up. Because like they all say created a month ago, except this one says created by IM.
Yeah, so that's me. So I'm going to quickly copy the login command and get myself access to the terminal. Okay, here you go. So if I quickly do that, and I'm going to make it a little bit bigger. So I did that, and OC projects. So OC projects, as you can see, all the things are printed out. So OC is the terminal command for OpenShift, right? Okay. And so I did OC projects, but one funny thing, once you have actually logged into OpenShift, it doesn't know what kubectl is. Oh, yeah, kl get ns. There you go. You have to kubectl get ns. So you'll see that the namespaces are exactly the same. If I do OC projects and kubectl get ns, you get the same namespaces.
Right.
And you can actually use kubectl for these are some things that are already running, but you can use kubectl for exactly the same things OC you can use for. OC and kubectl almost work similarly, but basically OC knows about more API resources than kubectl.
Gotcha.
So if I do OC API resources, you'll see I have a bunch of these extra CRDs that wasn't available in Kubernetes by default.
Right.
Things like, Kubernetes, OpenShift has some extra authorizations, so some security things that are baked in. Things like no root access or like secure by default, SELinux, AppArmor. All these things have like extra features that are built into OpenShift, makes it more secure. Right? So you see a bunch of things OpenShift here. You have a bunch of OpenShift things here. Images and image streams are really cool. We're going to look at that in a second. But the way OpenShift does it, that OpenShift actually has a built-in image registry on the cluster. So when you push your image, you don't actually have to go to like a private image registry. You can just push the image, build the image in the cluster and push the image in the cluster so that when the application runs, it can just pull the image back from the cluster.
Gotcha.
So it makes like CICD in the cluster much easier. It also have Jenkins integration built into cluster. So you can run a Jenkins pipeline that is running in the cluster.
Gotcha.
So you can also run GitLab in OpenShift. You can do that on Kubernetes as well. But OpenShift just has like easier way to run this. And basically your entire workflow becomes GitLab running on Kubernetes. So you push your code to GitLab, say, and GitLab starts off a Jenkins job, which is also running on Kubernetes. That job creates an image, which sends it to image registry, which is also running on your cluster. So the entire thing kind of gets isolated in the same thing. So if you are concerned about security and sending your context back and forth into multiple of the services, OpenShift is pretty great for that. So like that's why it's for enterprises. It brings a lot of value when you can encapsulate and isolate all your workload into one of this like solution like that.
So instead of like pushing your code to GitHub, you push it to your OpenShift.
Probably. You could do that. Again, it's not necessarily like you have to do
Right.
that. It has actually really great webhooks built in for Git as well. So in Git, you can set up webhook, and every time you set up a build here, it gives you a webhook URL. So when the moment you make any change to your Git, you can actually start a job, like a build of your code, or you can start a Jenkins job automatically.
Gotcha.
So OpenShift creates webhooks for you automatically.
Nice.
You could do that yourself, of course, but it's just like all these things. So
Right.
The idea is application first. All these things are first-class citizens in OpenShift rather than being something you have to custom build yourself.
Gotcha.
Okay. So also OpenShift comes with many monitoring tools built in, like Prometheus, CoreOS, Prometheus Alert Manager. It has, I think, Grafana also built in that you can use. Okay. So with all that, you can actually look at all of these things in Kubernetes as well, because Kubernetes also knows if there is CID installed on my cluster, kubectl also should be able to see those. But kubectl won't be able to use all those things because OpenShift. OpenShift and kubectl actually has almost the same binary, but OpenShift just has a little bit more extra things on top.
Gotcha.
Okay, so let's go back to our cluster. And it's yelling at me for copying the IAM and telling me to make sure that I don't give away my IAM key because those are important. So I'm going to create a new project. I'm going to quickly show how this process looks like. So I'm going to call it test. And just created.
Beautiful.
So I'm going to go to the project. And I want to then deploy an application in it. So I'm going to browse the catalog. And the application I'm trying to deploy is written in Node.
Okay.
So I'm going to choose the language Node. And I'm going to say next. And here, they have a sample repository, this one. Let's look at what the code looks like on that repository, right? So in this repository, as you can see, there is a server.js. There's some bunch of things there. But one thing you see there is not there is the Docker file. So there is the Docker file here. But
It's in the OpenShift folder.
Yeah, so even if you go to the OpenShift folder, right, you wouldn't see the actual Docker file there because we're just passing it the root, and I'm saying the application name is this, and I'm going to just say create at this point, right?
Okay.
And see what happens. If I go to the overview, you will see that it actually started a build. Build 1 is pending. It's going to start. You will see that it's cloning the repo. It's going to do a bunch of different things. We're going to actually click on view full log so that you can see most of it. And look at the code. And since we chose Node, it knows to use the Node builder image. So it's going to then go ahead and use the Node builder image and actually push the image to the Docker registry that is actually in my cloud, in my cluster, Docker registry.default.service:5000 / whatever. So it's doing all the thing. It's pushing the layers, and the push is successful. And eventually we'll see, if we go back to our overview, we will see that it has finished building the thing. We have one copy of it running. It also created something called a route. So route, again, is almost like an ingress, but it's better. It's secure. Also, it can set up let's encrypt and make it secure if we wanted to. We didn't select to make it secure this time, but we're going to do it in an example in a second. But the point is it deployed the application, set up a service, set up a route, and it's available on the internet, basically without any pain. And it also figured out we're using Node, so use Node to build the image. So all that stuff just happened.
So how does it know how to build? Like, does it use a specific build?
Yeah,
in
so
the package
it
system?
has something called the builder image. And so this is the image it built, but I forgot where the builder images are. But there are like base builder images baked into OpenShift. You can write your own for if you choose a language that is not automatically like in this list, like here. Right now, the languages by default it's supported is Java, JavaScript, .NET, Perl, Ruby, PHP, Python. But I know for a fact you do a lot of Swift stuff, right? I do a lot of Go stuff. So if we want to do that, we can write our own builder image. Builder images are nothing but basically looking at a code, how would you build it, package it, and made it the image out of it. Like you write that logic into another Docker image or container image.
Right. Can I see like the package JSON, like the example node thing?
Oh, okay, sure. Here you go. So again, whatever package.json has, it basically copies the way you would build your Docker file, right? If you look at all the node images you have created, node applications you created Docker files for, you're gonna see a pattern, right? Docker files are pretty much similar everywhere. So basically, OpenShift made that automated. Instead of you writing the Docker file over and over again,
right.
Basically, if you think about it, if you wrote 10 applications, you could probably use 70 or 80% of the entire Docker file across all applications. So it's the same idea. They basically just look at the package.json, do the npm install, get all the things, then copy your code into the Docker image, then finally do npm start. That's
right.
basically.
So my question is, so like for my application, I can't just npm install and copy the code. I have to like also like build it. So like, does it look in the package.json for like a build tag or in the scripts?
Yeah. Also, like again, if your code is not like suitable for this automated build to happen, you can just still keep putting your Docker file, and it will take your Docker file to build the image if it needs to, if it can understand what you're trying to build.
Gotcha.
Right. So, and most people already create a Docker file because they want to custom build and really make sure that Docker image is the smallest. We talked about this.
Right.
Like how to make your Docker image. So like I probably wouldn't necessarily trust like a builder image to build the most smallest, because I know how my application behaves, and I can probably do the best packing to make sure my application is the smallest.
Gotcha.
So, but like for general use cases, it just works for the most part.
Right.
So we do that, and it works. So that was like the very simple, easy example. But even in this easy example, they actually did a bunch of things we didn't see. So in the build, it actually created a build config. In the build config, it actually also created GitHub webhooks. So if we had access to the source where it was building from, we could set up this webhook, and every time there would be a change in my code, it would then push all this change to this and start a new build. And so you can use GitHub webhook or just the generic webhook to any Git you're using, either using GitLab or like name a couple more. Atlassian has one.
So like if so in GitHub we would create a GitHub Git hook.
We're gonna build that in a second. We're gonna see that as well. But cool. Yeah. So okay. So let's go back, and I'm gonna actually delete this particular test one because it doesn't serve us too much of a purpose. Test.
And then I also saw there was like the OC build, so you could like manually build it.
Yeah.
Too. Okay.
So you can manually build it, but today we're gonna mostly like stick to the console, because we're gonna have another day. We're gonna just jump really deep into how we can do everything from a terminal, because I feel like a lot of the users coming from Kubernetes, because they're so used to kubectl, 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 whatever you call it. People are more used to like kind of the terminal way of doing things. And again, OpenShift developers took into consideration both ways and made it so that no matter which one you choose, you can do everything you want to do in both the terminal and the web. So let's get started on, so we have a demo application that we built for OpenShift 101 workshops, and it's called Example Health. And you would see there is a project already running for Example Health. I can quickly show you what the application looks like. This application already has the webhooks and everything set up, but I'm gonna quickly go to the UI and show you the example. So this is basically a patient data thing that it's all mock data, so you don't have to concern about we're leaking patient data. But we use the tool to create some mock data, and it's there. And I'm gonna just like username and password that we have created, and it'll basically show you this particular like a random user called Ralph, and some information, some map information, and all the medication they take and things like that. So some BPM, how the application is built, all this stuff. And you can actually also create like a backend yourself. You can deploy the backend and put the URL here. Right now it's just using demo mode, but if you deploy your application as a Java backend here, you can put the URL here, and the application will actually use the backend there. So it's a pretty nifty little application. So one of our friends, you also know Max, worked on this, and we have this application. So let's go ahead and redo this, like deploy it ourselves. First thing we're gonna do, we're gonna create a project. I'm gonna call it Health, and Another thing you have to have is also that because we're going to use the Git webhooks, we're going to need to have this application like deployed or forked on our profile. Let's just quickly figure out where do I have that, because I should have this somewhere. Okay.
How hard do you think it would be to just take my Cloud Annotations GitHub and deploy it?
It's probably a half an hour task. It's not too difficult. OpenShift, again, if you just keep everything as is, just switch your cluster to your OpenShift cluster, it would still technically just would work. And then if you change a couple of things, like probably like set up a Jenkins integration within your cluster, yeah, another half an hour to 1 hour work. We can probably like do that sometime next month, and we can make that happen. Move to OpenShift, make it cooler. So right now, see, this is the fork I have. And I'm gonna basically just take this URL in a second, and say I have the OpenShift and everything set up, and I can in my cluster I can see that OC get nodes. Again, these are the same commands you would do on Kubernetes, kubectl get nodes, and they would look almost exactly identical, except for spaces and tabs here. I don't know what happened, but you basically get the same exact thing. So I have the code here, and I have the console here. We're going to do this from console today. Maybe some in the future time we can do that from the cluster. So exercise 1. So we want to browse the catalog, figure out we want to deploy a node application. So you can drop down to node, and here go next. So application name we're going to set as, you can give it any name, but let's give it health. And Git repository, instead of actually, we're going to, also the application we are using actually doesn't live on the root, it lives on the site here. So we can actually do the context path as well. So you're going to go ahead and do that. Come here, yada, yada, yada. So for me, my repo is this. You do this and do site. And you can see I have done this before. And I don't need a secret. Also, if your Git repo happened to be like a private repo, you can actually set up your Git secret here, and that would know how to pull that image.
Nice.
So that's pretty solid that way. And we're creating a route automatically. We're going to make it a secure route that would actually set up your Let's Encrypt certificate so that you can get a HTTPS route here as well, so which is pretty nice. And I don't have to pass it will generate it automatically, and everything else looks great. You can also set up CPU limits and all other stuff, which is good to do. I'm not doing that now, but you can do that. It sets up a label automatically, and with all that, I'm going to just say go ahead and create this. Another thing you'll see that right here, it actually already gave me a GitHub webhook, right, even before I did anything. So I'll just copy this for now and come back to that in a second. But we're going to use the GitHub webhook. Since it knows I'm building this code from GitHub, it gave me a GitHub webhook. If I were to build this from GitLab, it will probably give me the generic webhook. But I have the GitHub webhook now that I can use to set up my. So I already have a webhook set up here. I can probably set up another one, which is totally fine. So I already have one set up here. And I'm going to add another webhook. And it's going to require me to put my password, because why wouldn't you? And payload URL is, why is filling out my name here? This. And you want to send it as application JSON. And the secret I'm going to get actually from this. This is the secret. And SSL verification, everything. I'm not going to set the webhook just yet. I'm going to actually let it finish build. And I'm going to go to overview. You'll see that it has finished the build, set up an URL. And the URL you'll see is the HTTPS URL.
Nice.
Because again, we selected secure. And because we selected secure, it set up the Let's Encrypt certificates and everything.
How hard is it to like do a custom domain name?
It shouldn't be too difficult. Again, the custom domain name wouldn't be as like just like a click or something. You'll have to set it up yourself a little bit more. We can investigate. Like again, we spent one day. Last time we tried doing it in Kubernetes.
It was more than a day. It was like a week.
I mean, we like in terms of like I have the recording in WebEx. We spent literally 4 hours, 6 hours recording, like just like banging our head.
Right, and it didn't work in the end.
It did work, right? Like when we changed it to 80 instead of 8080, it just worked all of a sudden.
I think so, but then there was
some other
stuff.
Okay,
yeah.
But again, we got it done. That is the point. And so basically, it's running again as a thing. And what we want to do next is that we're going to add this webhook. And the webhook would be this URL, the secret, we got it from there. The thing I wanted to show you, just in case you didn't copy it at the moment, you actually OpenShift is nice so that it sets it up actually here. If you lost it there, you'll actually find it here, right?
Nice.
If you can't find it there, you can actually go to the YAML, and the YAML actually has it there as well. That's the secret, and the path should be here somewhere. But it gives you the secret. If you can't remember where the secret is, you can find the secret from there. And the URL is right there. You can also like just, this path is also set, like prefixed. So like it's gonna be like your project name, your repo name that's fixed, then APIs, then build, then the project name, then build config / then application name, then webhooks, then the secret, and then / GitHub because it's a GitHub secret. So you can basically just recreate it even if you lost it. You can also find it from the terminal if you need to. But all that point is, if you didn't copy it at the beginning, you can find it. It's not lost forever. So with all that, I'm going to just add this webhook. And I don't have to save this, but the webhook is set. And I think this is the new one. This is the previous one. I have both webhooks set, whatever, it doesn't matter. Git can do whatever it needs to. So the thing what I'm going to do here is I'm going to change something on my application. Let's go in the index.html. And let's change something to something that people can probably just log in and see. What should I change? Example, maybe the name?
Yeah, change the name, and let's change the page title to Mofi is dumb.
All right, we could do that. I mean,
or cool. I guess you're pretty cool. You're
thanks.
showing me this cool Openshift.
So demo health, Twitch stream, right? I can just like, right? You can
I'm
call
not
it.
even gonna see that. It's gonna be like clipped.
It's fine. I only have 3 tabs. You see like how many words you can see up top, like app to app idea to OpenShift Google. I think, yeah, or like demo Twitch stream. I can just like call it that, even make it smaller.
Beautiful.
And I come back here, call it demo health streams. I don't know. Cool like that. So if the moment I do this, I commit changes, that is a push, and I will see that if I come back here, that should start a new build. Build 2 is running. Again, nothing too crazy. If anyone who understands webhooks, the moment we did that, GitHub made a push request with the changes onto the endpoints that are set as webhooks. And OpenShift was listening for it, and the moment it happened, push finished. We had one pod on version 1. It was scaling down to 0. That one is scaling up to 1. And done, right? And if I just go back to this, you'll see, ooh, something changed back to something.
Shift R.
What's that?
Hard refresh.
Command Shift R?
Yeah.
Didn't do anything. What? Okay, you know what I'm going to do? I'm going to open it up in incognito.
Clear your cookies. Close that tab before you open it.
I think it's... Oh, I think I changed something else. But like demo, it says demo health here. Hold on, let me check it. Point is, it did change. Oh, I changed the second page. Here we go. That's what I did. And that's the word I changed. I don't even know what I changed. So that's what I changed. There you go. I think that was working there as well. This is the login screen that comes before.
Right.
And we just changed the index, which is this page. So which did change, demo Twitch stream. And, all right. So the same like thing can be scaled over to if you set up your Jenkins pipeline, and then you can use the webhook. Every time you push to Git, that'll pick up the Jenkins job. That'll do all your testing, all your building, pushing the image then into the image registry, which is also running on the cluster. That will then kick off the build with the image, with the new update. So you can do that all within the cluster and on the same Git webhook. And it will be like the flow would be a lot more concise and a lot more controlled on from the user point of view.
Yeah, it's actually kind of nice.
Yeah, no, I think.
I was gonna be annoying and not want to use it, but
yeah, I broke you down, I think.
Yeah.
Yeah.
And I'm not just saying that.
Right. And another thing is like that it actually also comes pre-baked with monitoring and things like that. So you can look at what are the things, you can look at the logs right away. Builds, what are the builds that happened also right away, right there.
I'm still really skeptical that pushing my cloud annotations to it isn't going to be a nightmare, but that'll be the real test for me.
Right. I mean, again, it still could be a nightmare. I mean, nightmares are only like dreams waiting to happen. I don't know, like I'm just trying to be philosophical. I don't know if it worked or not. But so you can look at like the logs and things like that, whatever happened to this thing. I'm still looking for how would I monitor this. Hold on. Oh, all the events. So if you have, also in Kubernetes, you can just do things like kubectl get events and spell events. That's key to spell events, right? And it will tell you all the things that did happen in this particular cluster, right? So you had some successfully catalog entries from broker. I don't know what is that about, OC projects. So the reason we're getting that right now because we're looking at the default project. That's the project we're not using. So we're actually using OC project health. And if I do OC get events, you'll see all the events that happened, right? And like that's the events you can also see from the terminal. In Kubernetes, if you don't know the CLI commands to see all that, it's pretty difficult for you to like see those. But in Openshift, they made it pretty simple for you to like see the events and all the things. Anything you could do, and so the key is anything you could do on your CLI, you could do that on the.
So like, how would we like set up the replicas and all that other fun
So
stuff?
again, you can if you want to set up replicas, you can either set it up on a deployment config. You still have access to deployment configs and such if you want to still push YAML.
Or in this GUI, how do we do it?
In the GUI, you can just come down here. You can just like, bam, it's 2. Right, and if you don't want to like be able to like do that, you can now also edit, and you'll get access to. You can here when you're actually first deploying, you could say how many replicas you did want. Let's say you come here, go to build, go to here on the build, and you come here and edit the build. Here, show advanced option, and I totally forgot where you do it. This is a shame. So a couple of the things here, the image configuration, that's the image they're building with. So Openshift is a Node.js version 10. If you have other Node versions, you can also select it there. I am totally blanking here. Let me figure it out. Hold on. So you have this. That's the health, deployment, action, edit. It should say replicas. Okay, let me just look at the YAML and we'll figure it out. Edit YAML.
Replicas.
You see replicas? Yeah. So replicas. You can if you just change these replicas to 5 and save this will be the YAML deployment that we're doing. And if you come to overview, you'll see that it's scaling up.
Wow, that's fun. All right, what about, I think I have like a Redis thing. How would I add that into here?
Well, Redis, if you're just doing it as an application, you can just like put a Redis pod in here as an application. That would just work. Also, Redis, we can have like a pre-baked Redis deployment. So it has few databases pre-baked into it, like Postgres, MySQL, Redis, and Mongo, I think, and MariaDB. So you can Redis, you can just like deploy it like that, and you will get an URL for your Redis that you can call from your application.
Okay.
Yeah, and also, or you can just set up. So in your applications, you can also set up things like if you come here and go to your application, just like that. You can also set environmental variables here. So maybe your Redis connection can be an environmental variable that after you get the Redis connection, you can just set it here, and the application will be able to read it. Cool. From this. So this was basically kind of like an overview of OpenShift, and I hope like we changed some minds. So here's the thing: if you're already using Kubernetes, I feel like the value of OpenShift is pretty clear. If you're not using Kubernetes and you feel like you have no use for Kubernetes just yet, I don't know how much value OpenShift would just like add to change your mind. It could.
I feel like OpenShift, to me, it feels like it's a lot easier to start with than starting with Kubernetes. Yeah. Like I can just point it to my GitHub and I have an app running, where with Kubernetes I had to it was a nightmare trying to go through all
so
that.
I feel like
and then you can scale to something more like Kubernetes-esque, like once you're.
Well, yeah, technically OpenShift is already beyond Kubernetes, right? It's already running on top of Kubernetes. For example, if I were to just show you kubectl get pods -- all. If I could type to the namespaces, and I spelled it wrong. So these are all the things that are running, and you'll see there's a bunch of kube system things. Those are things that are coming from Kubernetes. There are some IBM system things. These are basically because of IBM cluster. We're providing some security measurements from IBM. They are my application, but in the bottom you'll see there's a bunch of things that are OpenShift centric. So for example, the web console is basically an application running on Kubernetes. That's the web console that gives you.
Right, I'm just saying it's like, it seems to like a new user, it's like as easy as pushing to Cloud Foundry.
Or like Heroku, yeah.
And then, but you have like the fine-grained control of Kubernetes
underneath. Yeah, so that's basically literally the point of OpenShift in my opinion, right? So you have something that makes Kubernetes a PAAS rather than just this thing between IaaS and PAAS. And some people actually labeled it CAS, Container as a Service. So OpenShift is going more towards like more about application than about the platform, right? So when you run OpenShift, you don't really care about which cloud you're running it on. Are you running it on bare metals yourself or all that? But because the moment OpenShift runs and you get it set up and running, it's basically just OpenShift. Doesn't matter which cloud you're coming in from. So with all that, I think OpenShift is a pretty solid place for people to get started and learn and like build things. They have the OKD distribution that is open source and free. Anyone can deploy that. They have licensing for like enterprise level stuff. So I think with that, we're going to stop here. What do people have to look forward to next week? I think we're traveling next week, actually.
Oh, yeah. Yeah, we will. We'll be on a beach.
Yeah. So we're going to Caribbean Developers Conference, and we're both really excited to go there and speak this year. Hopefully we can do a stream from there if the internet actually does support. But I think that next week's stream will be more about just general things. We can like probably grab a couple of people and get them to like talk on our stream as well if we can. But other than that, we'll see you the week after, hopefully, if we're not traveling again, which might be a thing. But whenever we're coming back to a topic Nick is teaching. So Nick, if you could give us a preview of what we
don't know yet.
Don't know.
See.
Okay.
We'll probably, get back on track with doing like the next lesson of AI. I think last time we did convolutions.
We did MNIST stuff.
I don't think we even.
Well,
we didn't even code last time.
No, we didn't code.
So yeah, next week we'll be coding with convolutions.
Looking forward to it. I'm just like skilling up, as they say, on my JavaScript. I still can't wrap my head around the no type thing yet, so I'm still working through it. But I come from a long line of typed languages like C, C++, Java, and Go. So it's a big shift. But I'll get there. OpenShift. Anyway, so thank you so much for joining once again with us, and see you next time, I guess. And I have to find how to close this. Hold on. There we go. Okay, this time, really bye.